Well, now we're ready to practice writing formulas in which we're given a name and we quickly identify that the name of the first atom in there is a group 1, 2, or 3 metal. And today I'm going to say and ammonium, NH4 with a plus on it. That's on your anion sheet. It's the very first one. That happens to be a cation on the anion sheet. But we're going to treat ammonium like a group 1 metal because it's always going to be NH4 plus. So we're going to do it the same way as we would do naming a compound, or writing a formula for a compound with a group 1 metal name in it. Okay? So in these cases, what we'll do is when we look at the name, we'll look at the first element, find out that it's a group 1 metal, and know that what's attached to it's an anion. So here is my suggestion for 4 kind of quick steps to do that. First thing is write the symbol of the metal and use the group number as the charge on the metal. All right? So if my metal is something like sodium, and I know that's in group 1, I'm just going to go ahead and put a +1 on it. If it's something like barium, that's over in group 2, so I'm going to put like a 2+ on it. If it's maybe like aluminum or one of those in the group 3, I'm going to put a 3+ on it and have that at my fingertips. Then I'm going to look at my anion sheet and I'm going to write the symbol for the anion and I'm going to put its charge on it. Okay? So let's say you had something like sulfate, so on your anion sheet that looks like SO4 and it's in parentheses and it's got a 2-. So I'd go ahead and do that. All right? All right? That is a -sign. All right, now I'm going to determine the lowest common factor. Now what we mean by that is essentially taking those charges and multiply them together and find out the lowest multiple that both the positive charge from the cation and the negative charge from the anion divide into. Okay? So we're going to multiply them together. So if I had something like 3 and 2, my lowest common multiple would be 6. That's the lowest factor that both of those divide into. Now if I had 2 and 2, I got to be careful because really the lowest common factor here is 2, not 4, right? Because 2 will divide into itself. So we'll talk about that as we put these together, but I got to be careful about that. All right, then to figure out what the subscript is on the metal atom and on the ion, or the anion, we're going to divide that common factor by the charge on each symbol. All right? And we're going to then use that number that we come up with from that division to be the subscript for that metal or that anion. All right? So let's look at our example to see this in practice. All right, here's our example. We're given the name aluminum sulfide. All right? First thing I'm going to do is come down and write aluminum. I'm going to see that it's in group 3, so I'm going to go right ahead and put a 3+ on it. I'm going to go to my anion sheet and find sulfide and write S, and from the anion sheet it's got a 2- on it. All right, so my lowest common factor then would be the 3 times the 2, or 6. All right. Now this goes back to step 4 on the last sheet where we said to determine how many of each of those atoms I need in my formula. I'm going to take my common factor and I'm going to divide it by the charge on my atom. For the aluminum, I'm going to take the 6 and divide by 3 and get 2, so I know that's going to be the subscript on my aluminum. All right. And for sulfide, I'm going to take that same 6. This time I'm going to divide it by 2 and find out that 3 is the subscript I need for sulfur. And so that's what I did. I put the 2 there. I put the 3 there. I write aluminum, Al2, sulfur, or sulfide, S3. So the correct formula for aluminum sulfide is Al2S3. All right? Think you've got that? Good. Then what we're going to do is, as always, we're going to practice some. Here are 5 that I want you to practice. Barium sulfide, gallium oxide, sodium carbonate, calcium phosphate, and we're going to throw in ammonium sulfite so you get used to writing one with ammonium. So, again, as we've done previously, put this on pause, write out your answers following our steps, and then double check it against this fourth slide here, which will have the right answers on it, and we'll let you compare. Then we'll talk through them if you didn't get all the right answers. All right, so put it on pause and go to work. Okay, you're back. You've got them all right. Barium sulfide, BAS. All right. Gallium oxide, Ga2O3. Sodium carbonate, Na2CO3. Right. Calcium phosphate, Ca3PO4 taken twice. And for ammonium sulfite, NH4 in parentheses taken twice, SO3. All right, if you didn't get those, let's walk through this. Here are our steps. Barium, okay, I'm going to write Ba, find it in the periodic table with a 2+. Sulfide on my anion sheet with a 2-. All right, if the positive cation charge and the negative anion charge are the same, it says they're in a 1-to-1 ratio, right? It says they're in a 1-to-1 ratio. So that means I just need one of each, okay? If you said, well, it's 4, so I need 2 bariums and 2 sulfides, and 2 sulfides, you can reduce that down. When you have 2 even numbers in there, you can reduce that down with these metal charges. So that would not be the correct formula. Again, I've got a 2+, I got a 2-, so they're exactly in the right ratio to get a total of 2+ for everything. So BAS is the right name, or the right symbol, I'm sorry. Gallium oxide is our next one. All right, so we wrote Ga. That's over in group 3. Oxide is a 2-. All right, so we know our common factor is 6 again, right? 3 times 2. I need, 6 divided by 3 says I need 2 galliums. And 6 divided by 2 says I need 3 oxygens, and that's how I came up with those subscripts. All right, now how about sodium carbonate? All right, we did Na, and that's in group 1, so that's a +1, and carbonate, that's a CO3, and the whole thing has a 2- on it. All right, so this time what? Our common factor is 2. 2 times 1 is 2. All right, so if I divide that by the 1 for sodium, it says I need 2 sodiums. And if I look at the carbonate, if I divide 2 by 2, it says I need 1 of the carbonates, 1 of the CO3s. Now you remember from what we've talked about and what you've seen in other videos, CO3 is all one thing. I do not usually put that in parentheses, right? Because there's only one of them, so there's no need for the parentheses. So don't put them there. We put the parentheses if there's more than one of those polyatomic anions. All right, going on to number 4 here, calcium phosphate. All right, so we write Ca, and that's in group 2. And phosphate on our anion sheet is PO4 with a 3-. So again, what? Our common factor is 2 times 3 or 6. So for calcium, 6 divided by 2 says I need 3 of those. And that's where I got that. For the phosphates, 6 divided by that 3- says I need 2 of those, and that's where I got that. Now, because there are 2 of those polyatomic ions, or anions, I have to put the anion in parentheses and then put the subscript outside the parentheses. All right, and so the last one here, ammonium sulfite. Ammonium on your anion sheet, like I said, right at the top, the only cation on your anion sheet, NH4 with a +, and sulfite is SO3 with a 2-. So again, our common factor here is 2. 2 times this, that's a +1. 2 times 1. So for the ammonium, the common factor divided by the charge says I need 2 of those. And for the sulfates, the common factor divided by the charge says I need 1 of those. All right, so that's how I came up with it. Again, here we've got a polyatomic cation, NH4, so we have to put it in parentheses to put the subscript 2 out there. And we've got a polyatomic anion, SO3, the sulfate, or sulfite anion. And since there's only one, we don't put that in parentheses. Okay, hope that in kind of a very short summary of how to do these. Again, this is probably time to go to your worksheet and practice, and then check them against the answers to your worksheet and see if you have them right. And if you do, then it's time to move on to whatever graded exercise you have for naming compounds and writing formulas. So that's going to end this video, and we're going to do one more on transition metals.